You probably know about the quadratic equation formula for doing things like finding the roots of a quadratic, but how do you find the roots of more complicated graphs? Especially something like a cubic equation or something like this graph here that has, one, two, three, four, five different roots. How do you find the roots of these more complicated equations where there isn't just a formula to put in the variables and get out an answer at the end? Well, there is an answer to this, and it's called the Newton-Raphson method, or the Newton-Raphson equation, you might say. But I think method is better because it is an iterative process that sort of tries something, makes a guess, and then tries again until it gets the right answer. So let me show you how it works, and then we'll talk about the maths for it. So the way it works is, say I'm trying to find a root for this graph. Let's say I'm trying to find this root in particular. What I would do is I would guess a root, right? Let's make the guess, and we'll call this guess xn, right? I'm going to guess the root is some number x. As we'll find out later, the guess we make does matter a little bit, but for now, we don't need to know what the answer is, we're just guessing an answer. What this Newton-Raphson's method does is it goes up to the formula and it plugs in this guess that we've made into the formula itself that has created this graph. And then it takes the derivative, the gradient of this point, and takes the derivative and takes it all the way back down to the x-axis. Once the gradient hits the x-axis, that is actually going to be our next guess. It says, we guessed that the root was over here. Our next guess of where the root is going to be is over here, x of n plus 1. And can you see how sort of our next guess is actually slightly better than our first guess? So that's good. It's given us an approximation of the answer, but it hasn't given us the answer itself. And the way that we get that answer is we just iterate. We do this over and over again. So whatever it gave us as the next guess, we plug that into our equation, and we take the derivative, and we come over to here. So it'd be x of n plus 2. And then that, we'd go up to the formula, up to the equation again, we take the derivative, and you can see that I've basically, with x of n plus 1, hit exactly the point I was interested in. Okay, so how does this actually work, or what's the actual equation? So the way we write the formula is we say that x of n plus 1. What does that mean? It means our next guess of what the answer is going to be, right? Our next guess of what the root is going to be. It's going to be equal to x of n, right? That is our first guess of what the root is going to be, minus the function f of x of n. So this is what happens when we plug in our guess into the equation, divided by the derivative f dash x of n. That is the derivative of the equation that we were just talking about. That is the basic formula for that Newton-Raphson's equation. But let's show you some examples to sort of see what this is. So I'll start with an equation that you can actually solve with a quadratic equation formula, and that is y equals x squared minus 1. What are the roots going to be in this particular case? Well, let's just find all of these things. So we're going to guess an answer. Maybe we'll guess x of n is equal to 2, right? That's just going to be our first guess. F of x of n then, right? What is the function? That's going to be 2 squared minus 1, right? Which in our case is going to equal to 3. And f dash x of n is going to be, well, it's the derivative of this. The derivative of x squared is 2x, and the derivative of minus 1 is 0, which means it's going to be 2 times 2, which equals to 4. So if we actually plug that in, we would have x of n minus f of x on f dash x. And you'd say, I've got 2 minus 3 divided by 4. So that's 2 minus 3/4. That's going to be 1 1/4, or 1.25. Now, you can probably tell that the actual answer to this is going to be x equals 1, or actually x equals minus 1. And so you can see that the answer has gotten closer. It's gone from 2 to 1.25. We could do this again. We could plug in 1.25, and we would get closer and closer still to the actual answer. So that's the process, but it's a bit time consuming, right? I have to give it a guess. I have to plug it in. I have to solve it, and then I have to put it in again. And I would start doing, 1.25 minus 1.25 squared minus 1 divided by 2 times 1.25, right? That would be my next step. And then I would solve that and get an answer and keep going. So it's a bit time consuming because it's iterative. What if we could solve this or get our calculator to do this for us? And that's what I want to show you today. So let's just take this as an example, x squared minus 1. So we've already said that f of x in this case is just x squared minus 1, and f dash of x is 2x. And our first guess is 2. So I'm going to go over to a calculator app, and I'm going to show you what I would do. The first step is I would put my answer, my guess in and hit equals. So I'm guessing x equals 2. So I'm going to press 2 and then I'm going to press equals. And what that does is that stores the answer, the number 2, as the answer in the calculator's memory. That's helpful because in the next step, we're going to actually use that answer when writing out our equation. So instead of doing 2 minus f of x divided by f dash of x, we're going to do answer minus answer squared minus 1 divided by 2 times answer. Now, the way this calculator works is when I press the answer button, it just does the 2 in the circle. So I didn't press 2, I pressed answer. It's just showing me that the answer it's reminding me is the number 2, but you'll see why you have to do it this way in a second. So I'll do answer minus, and I'll do a fraction, answer squared minus 1, and then in the denominator, 2 times the answer. I hit equals and see how you can see on that right-hand side, it's already showing 1.25 as the answer. That was the answer from our first guess. But if I press equals again, it changes to 1.025. And you can see the numbers in the formula without me typing anything have changed from 2 to 1.25 because it's just using the previous answer to calculate the next answer. If I press equals again, you can see the answer is now 1.003. It's getting closer to 1. And I keep on pressing equals, and eventually I get an answer that actually is 1, because 1 is the correct answer. So my calculator is doing all of that repetitive iteration for me. I just need to set it up once the first time. Okay, but you'll say, but the formula that you just showed me, the x squared minus 1, that's something I can solve with a quadratic equation. What's an example of something I can't solve? And so let me give you a bigger equation. Say the equation, f of x, is x cubed plus x squared plus 1, right? What is going to be the roots of this equation? That's not entirely obvious to me, so let's take the derivative. The derivative of this equation, it's going to be 3x squared plus 2x, and then that plus 1 is going to disappear because it's just a constant. And then I can take a guess, and here, because I've got a plus 1 in it, I'm going to guess x equals minus 2, maybe. This could be an answer to something like this. So I'm going to say my first guess, x of n, is going to be minus 2. So what do I need to do? I need to press minus 2 and then hit equals. That's going to be stored as the answer. And then I'm going to write answer, ans, minus answer, ans, again, to the power of 3, plus answer to the power of 2, plus 1. And I'm going to divide it by 3 times the answer squared plus 2 times the answer. That's what I need to write into my calculator. And so let's do that now. I'm going to start with minus 2. It's going to be my guess. And then I'm going to write answer minus fraction, answer to the power of 3, plus answer squared plus 1. And in the denominator, we're just doing 3 times answer squared. This is the derivative, plus 2 times the answer. Now it's already come up with an updated guess that is negative 1.625. All I need to do is press equals a few more times. Negative 1.485, negative 1.465, negative 1.465 again. And you can see if I keep on pressing equals, the answer number is now not going to change anymore. When the answer stops changing, this is how I know I found the right answer. I found a root. And so we can say that a root for this number is negative 1.465. So that is how you solve Newton-Raphson's method on your calculator. If you'd like to leave a comment, if you're still confused, you can ask about that as well, and I'll hopefully try and get back to you soon. Thank you for watching.